Okay, in the second part of today's PowerPoint, I'd like to talk to you about what is called the Doppler effect and standing waves. So let's get right to it. What is the Doppler effect? The Doppler effect is a change in the observed frequency of a wave that results from movement of either the source of the sound and light or of the person observing the sound or light. And again, the Doppler effect can occur in both sound waves and light waves. And I'll be talking about both of those as we move through here. To start with, I'm just going to use sound as my example here. As you can see in the picture here, we have two different people. One person is behind the ambulance, one person is in front of the ambulance. The ambulance is moving to the person on the right. Okay, and as you can see there, is we have a change, or as that ambulance continues to move, there seems to be a change in the wavelength. And this apparent change, or this observed change in the wavelength, causes a change in the pitch of the sound. Okay, and the reason that happens is as the ambulance moves towards the person on the right, the waves begin to overlap, and as they overlap with each other, this gives a higher frequency. It makes for shorter wavelengths. Okay, and the result is a much louder and higher pitched sound. The person on the left, the person behind the ambulance, gets the opposite result. Okay, as the ambulance moves farther and farther away, the wavelengths appear to get longer and longer. The frequency decreases, so the pitch goes down and the sound gets softer. This is what we call the Doppler effect. So again, we talk about pitch. And again, if the wavelengths are getting longer and the frequency is getting lower, then the pitch will be lower and the sound will be softer. If the object is moving towards the person, the wavelengths appear to get shorter, the frequency gets higher, and we get a greater pitch. Okay, this is what we call the Doppler effect. And as I said, this can also occur with light. And this is one of the ways that astronomers use and study the universe to see how the universe is expanding. And if we look up into the sky, we will notice that things sometimes appear blue, sometimes other objects appear to become red, or get redder, or get bluer. Okay, and that also has to do with the frequency of the light changing. Okay, as things move towards us, okay, just like the ambulance moving towards the person on the right, as stars move towards us in space, they have a tendency to have a higher frequency, and this makes them excuse me, appear blue in color. Something is moving away from us, that wavelength will lengthen and they will appear red in color. This is what we call the blue shift and the red shift. Okay, so again, this is the result of the Doppler effect for light. Okay, and you can see here what is happening. Okay, again, this shows you a star in space. If the star is moving towards someone and it's emitting light, these wavelengths overlap, or these waves overlap, and the star appears blue in color. If you're this person and that star is moving away from you, the wavelengths seem to lengthen, and the color appears, or the star appears to get more and more red. Okay, so we have a blue shift and we have a red shift. And again, we use this in astronomy to check on how things are moving towards us or away from us, and it helps us understand the expansion of the universe. The last thing I want to talk about are what we call a standing wave. The picture you see would be a standing wave for a string or a rope where the two ends are set, or one end is locked in place and you are moving the string around or the rope around. The result are nodes and antinodes. And again, this is what we call a standing wave. Okay. Here is an example of a standing wave. If you look at these points right here, if we were twirling the rope, say we were standing on this end and this was tied to a door handle, and we simply twirled the rope around, you'll notice that these points, where the arrows from the nodes are pointing, are locked in a place. It is the antinodes that are changing up and down. Okay, so we have nodes and we have antinodes. Okay, this is what we call a standing wave. So the stationary points of a standing wave are called the nodes, and then the loops of the standing wave where there is maximum oscillation is called the antinode. Okay, and this is what we call a standing wave. So just one of the last things that I wanted to talk about with you as you move on. Okay, the result is something called resonant frequency. And the resonant frequency is the frequency at which a standing wave occurs. So we have same amplitude, we have same wavelength, and that is called resonant frequency. Okay, and you can, if you know the wavelength and the amplitude, calculate the resonant frequency of a standing wave. Okay, so that finishes up the PowerPoint for today and our discussion of wave interactions, the Doppler effect, and standing waves. I'd like you to finish up your worksheet at this point, and again, once you have completed the worksheet, please watch the video over light. Have a good day.